directly address it to you.
Okay.
Yeah. Thanks very much again for your presentation. And it's time to move on to our next speaker, who is Igone Velez. Yeah. You hear me well, Igone?
Yeah, do you hear me? Yeah.
Okay. Yeah, fantastic. Yes. Thanks. So Igone is actually head of ICT division at Ceit, although she's been working in there for 20 years. And she's also a professor at Tecnalia University. And we'll talk about communications at high data rates and low latency and applications for 5G in the industry 5.0. So I'll let you share your screen, Igone.
Yeah, let me try this. Okay.
Perfect.
Okay, you are seeing you are now seeing my screen. Yeah, okay.
Yeah, we see. Thanks very much. All yours.
Okay, so after my colleague's presentation on 5G technology, I would like to focus on the potential applications of 5G in Industry 4.0, especially the ones related with high bandwidth and low latency. So let's start having a look at what market analysts are saying about 5G and Industry 4.0. Well, in this case, it's a report of McKinsey that says that by 2030, they expect to sell around 45 million 5G devices, and half of them will be related with Industry 4.0 applications. In fact, manufacturing is expecting to be a particularly strong driver, with the most important use cases that they expect to be related with automated guided vehicles or AGVs, real-time process control, augmented reality, and visual quality checks. And we will see this kind of samples in this presentation. So. According to the same report of McKinsey, it says that the first 5 use cases for Industry 4.0 that will gain traction will be those related with enhanced mobile broadband, and followed shortly by those using ultra-reliable low latency communications. So that's why I'm going to focus on these two characteristics. So first, the 1 millisecond ultra-low latency that 5G promises, compared with 4G that we have seen that it's in the hundreds of milliseconds, and the large bandwidth, which in fact are promising even peaks, that peak data rate of 20 gigabits per second. But what's interesting here is that they promise 100 megabits per second anywhere, even if we are moving at 500 kilometers per hour. So these two features are going to be, well, and also massive machine for IoT. So all the 5G technology will enable the pillars of Industry 4.0. So first, the potential of the Internet of Things will be developed using 5G, but the features of high bandwidth and low latency will be key for mobile robotics, flexible automation, augmented reality, and big data. If we think on Industry 4.0 or connected industry or even 5.0, we think on connecting production machines to have real-time information about what's happening in the plant. This is something that the industry is doing for a long time, but now they want to apply data analytics to predict problems in the machines. Now we are talking one step more where the products are also connected. This at the plant, we will be thinking about traceability. So we will know where the product has been, which machine has been used to produce it. And if we join it with the information of the ERP or mesh of the plant, we will know which machine parameters it has been produced. But above all, when we're thinking on Industry 4.0, we are thinking about monitoring the product throughout the whole life cycle, also when the product is working. So let's take an example of that we have developed together with Eurecat, that they produce screws that hold the blades of wind turbines. Nowadays, operators must go to the wind turbine and check that the tightening torque of the screws is correct. and tighten it if it's not, if they are loose. So what we have developed is a sensor system that is able to sense, which is this torque, the tightening torque, sorry. 5G will enable the connection of millions of such devices with low data rate, low consumption, so we can monitor the status of the products in real time. This gives the designer information about the use of the product. So Eurecat could improve their design considering the measured tightening torques, for example. It also allows what we are being talking about as servitization. So we could sell a maintenance services. In the example, the operators of Eurecat could be the ones that maintain the screws and went there if we needed to be. They needed to be tightened. And it will also give us not only information about the product, it could even give more information. So in this example, we are able to know how that wind turbine is working, monitoring the tightening torque. We are able to easily monitor which is the rotational speed, for instance, of the wind turbine. So it can even provide more information. So this is one thing that 5G could enable. But the low latency, characteristics of 5G will allow us not only to monitor what's happening to a product, but also control and act in real time. So, for instance, 5G could be used to control smart grids, where the wind turbine will be part of the smart grid. So in times of high energy demand, more power generators could be switched on, but we could also send commands to turn off some devices just for a few milliseconds. So we could, for instance, turn off some milliseconds those devices that have UPS, that they can withstand a small power outage without shutting down. So this could allow us to have a more efficient energy management of the smart grid. And this is in fact a use case of 5G that is already being tested in Northern Europe. If we go back to the industry and to a production plant, we will have sensors that communicate at a lower data rate, but with ultra low latency and high reliability. Of the production plant to see excuse me. But thanks to the characteristics of 5G, the digital twin of the production plant can also be seen in real time using virtual reality, so that the visualization could be even more immersive. We could use this digital twin to make virtual visits to the plants. It could also be used to train new operators or even to simulate new layouts or movement of products throughout the plant. In the image, we can see a digital twin of the Airbus production plant. In this case, the inside of the plane or the cabin is being assembled. And in this twin, we have collaborative robots, mobile robots, and people who assemble in the cabin and that are interacting. And this digital twin is now allowing Airbus to optimize the assembly, analyzing issues of ergonomics of the person or reduction of the product movement. But after the optimal assembly process is selected, this digital twin can be used to train operators using virtual reality. And through 5G, we could use this virtual twin to monitor the assembly process in real time and compare it against the digital twin and to detect unproductiveness or process improvements. Okay. Increasingly, the quality of a product is the most important factors for customers to select one product from all competitors. So this means that companies or productive companies should guarantee the quality of their products through inspection and quality control systems. And to do this, we can use different kinds of sensors. Among those visual sensors, which is the case as in the example I'm presenting you, where we are monitoring the quality of a gear, and we see with a camera whether it meets tolerances, or if we are using electromagnetic fields to see if it meets the harness requirements. In general, we will have even more inspection systems in the production plants, and based on high resolution cameras, or which will need a high bandwidth, and we will not be able to place these cameras always next to a network point with fiber optic access. So, in fact, this processing of these images requires powerful and expensive hardware, which also has to be maintained. So, 5G will allow to have a reliable wireless communication of these images, so we can send it to the cloud or to the edge, where we will have almost unlimited hardware resources and a small maintenance cost. Yeah. And going back to what Inigo was not able to fully explain, 5G can also be used for positioning. So a positioning system provides, as the name says, a position of a device in a coordinate system, and those based on radio signals usually measure the time of flight of the electromagnetic signal to calculate the distance between two devices. These positioning systems can help improve plant logistics, so we can trace the path followed by a specific product. Of course, the accuracy of the system is important, because we need to know whether the product has been working in this machine or in the other one, so the accuracy should be good enough. If we have a look at the current positioning systems, outdoors, the most well-known is GPS. Gives a position with an error in the order of meters, and current cellular technologies, 4G and so on, it can be used to calculate the position outdoors of the position of the mobile for outdoors, but the accuracy is worse than GPS. In fact, at the moment, ultra-wideband is the technology that provides better accuracy indoors, and it allows us to have an accurate movement traceability of the product, and we can somehow make a heat map of the movement of a device, and we can see where it has gone, where it has been for a longer time, which is the yellow part, or which is the distance it has moved around the plant. In general, we can use it to follow any product or tool throughout the plant, or even for security of people in restricted areas, or optimizing the logistics. And the current version of 5G, so we are around here in between release 15 and 16, promises around 3 meters of accuracy outdoors and indoors. But for future versions, so probably release 18, we will have accuracy similar to ultra-wideband, so around 10 centimeters outdoors and indoors. And this will be so because 5G antennas for millimeter wave, so the band of 26 gigahertz that Inigo was talking about, will be more directional, and we will be able to measure the angle of arrival and not only the time of arrival as we are doing with 4G. So another application could be monitoring of mobile robots in an industrial plant. Currently, we already have mobile robots that transport raw materials or finished products from one point to another of the plant. Those are called AGVs or autonomous guided vehicles, and most of them have a magnetic wire embedded in the floor that the AGVs can detect and follow the path indicated by the wire. And the guidance algorithms are implemented in the AGV, in each AGV, which makes coordination between AGVs quite difficult if there are many in the plant. The future of Industry 4.0 leads us to production plants with even more mobile robots, which will not need this magnetic wire, so they will be totally autonomous or intelligent. So we will also have collaborative robots, so those that detect that there is a person nearby and stop, so that they don't endanger that person's life. And it will be a mixed environment with people and mobile robots moving around. So in this environment, 5G will allow us to centralize the control of these robots, so that the central control knows at all times where each AGV is, where each person is, and we can send commands to each vehicle in real time. So stop here because there is a person here, change your route, now go to another place. And for this, we need the low latency that 5G provides us. The fact that the control of all the robots are centralized can allow us what's called flexible automation, which means that we can change the layout of the production plant in real time. For this, the digital twins that I have already presented will also be used.
Igone, sorry that I interrupt. You have about 1 minute.
Okay.
1 minute, 2 minutes more.
Okay, perfect. So some option that I was going to present is the 5G that will also allow us to work with augmented reality, as we will, as an expert, could help an operator explaining him or her how some machine could be repaired. Using augmented reality in real time, and in this case, once more, what we are going to do is most of the processing will not be done in the glasses, but it will be done in the edge or in the cloud. So we will make cheaper hardware and more wearable in this case. Last solution I wanted to present was about surgical operations with robots. It's an example that is in health, but this can also be done with real robots in a production plant. Currently, when a surgeon operates with a robot, the surgeon is present here, but the low latencies that 5G allows us to work with haptics. Which and as 5G is ultra reliable and has this low latency, the surgeon could be anywhere in the world and could operate anybody that is somebody in USA that could operate somebody in Spain, for instance. And examples of this, we can see that last year we could see this news was about the first 5G telemonitor surgery was done in Barcelona. This was just a video communication between the surgeon and experts. But this year we already have seen the first surgery using 5G. In this case, the surgeon was operating a cadaver, not a live patient, but it will be the first step towards this idea. And last, there are other solutions or applications of high bandwidth or low latency for autonomous vehicles or video surveillance. That's in fact, there are many other applications where 5G could be used, and let the imagination run, and you could think of many other ideas. And that's all for me.
Thank you very much, Igone, for this fantastic overview. I really enjoyed it, and I see all of these applications seem very futuristic, but I'm very happy that they are here already. So I see here a question from Santiago saying, do you think 5G is something for big factories, or do you see it also applicable to smaller factories or companies in terms of price, amount of data available?
Okay, I think that big factories are going to really exploit 5G because they will place their own base stations and their own 5G system. But small factories can also make use of this because it will help them have access to computing in the edge or in the cloud in a cheap way, and we will not need so many hardware, as I was saying, computing the video quality control or the AGVs control. So I think it's really interesting also for them.
Okay. So if and Carlos Alfredo asks, high bandwidth is directly related to low latency?
No, there are different within the triangle that you was talking, there are three different cases. So usually high bandwidth is one thing, and low latency is another. So we could have low latency with no high bandwidth, but there are cases where we will need both. So high bandwidth and low latency if we want to process video, for instance.
Okay, I see. It's a very interesting technology. Honestly, I'm fascinated. So, Igone, we are a bit getting short of time.
Yeah,
Thank you very much for your talk.
Yeah.
If you can leave your email